Hello guys, it's Mr. Faizan. This is grade 7 math revision for semester 2. The topic that we are going to revise now is simplify algebraic expressions. By the end of this topic, my objective is that I will be able to simplify algebraic expressions by identifying and combining like terms. Let's have a look at an example. What are like terms? I have got term 1, term 2, term 3, and term 4. Now each term is different. The first term, we have 3x to the power of 2. Second term, I have 4x. Third term, I have minus 5x. And then finally, the last term, I have 8. Going back and looking at the first term, the numerical value, so the number before a letter, is known as a coefficient. So we have a coefficient in the first term, we have a coefficient in the second term, we have a coefficient in the third term. And then finally, we have a constant. So the number 8 will not be known as a coefficient because we do not have a letter. The letter after the coefficient is called a variable. So here we have the coefficient 3, variable x to the power of 2. The second term, we have the coefficient 4 with the variable x. The third term, we have a coefficient of negative 5, followed by a variable x. And then lastly, we have a constant, a number. Now, within the 4 terms, we only have 2 like terms, as shown in the example. 4x and negative 5x is a like term. How do we identify like terms? So again, looking at term number 1, we have 3x to the power of 2. The second term, we have 4x. Now you might say we have the same letters or the same variables. However, x here is not to the power of 2. Also the third term, x is not to the power of 2. Because we cannot see the power, now we directly assume that this is to the power of 1. As it's to the power of 1, there is no need for us to write down 4x to the power of 1 or negative 5x to the power of 1. Along with the constant, we do not write down 8 to the power of 1. So in this example, the like terms that I have are 4x and negative 5x. So this means we can simplify this algebraic expression. Let's have a look at an example. We have 4x plus 3 plus 6 plus 6x plus 7x plus 4 and plus 9. To make it easy for myself, what I'm going to first do is collect all the like terms together. So let's do that first. So first of all, let's write down 4x. So I've got 4x plus 6x plus 7x. Let's pick up all the constants that we can see. So we've got plus 3 plus 6 plus 4 and plus 9. So these are all the different terms that we have. To make it clear, let me just write down, because there's a watermark in the middle of the page. So let me just write down here. So we have 4x plus 6x plus 7x. Then I'll get all the numbers and write all the numbers down, all the constants, plus 3 plus 6 plus 4 and finally plus 9. Now, let's collect all the like terms together. Now remember, the variable is to the power of 1, the second term, power of 1, the third term, power of 1 also. So we can add these together. 4x plus 6x plus 7x equals 17x. 3 plus 6 plus 4 plus 9. This we're going to have 22 total. 6 plus 4, 10. 10 plus 9, 19. 19 plus 3 equals 22. So finally, if I'm going to write this down, all I need to do is write down 17x plus 22. Here I have simplified my like terms. So my expression, my algebraic expression, I have simplified to 17x plus 22. Let's go through some examples. I have 15x plus 2 minus 4x plus 1. So my role now is to solve and to, well, not to solve, to simplify the expression. Can I, first of all, let's have a look. Can I simplify this expression? Do I have like terms? So I have 15x. Next, I have minus 4x, again to the power of 1. X, the variable, is to the power of 1. So yes, I can simplify 15x with minus 4x, and then I have a constant 2, and then I have a plus 1 at the end. So yes, I do have like terms. So all I've got to do, collect the like terms together, 15x minus 4x, and then plus 2, and finally plus 1. Simplifying this is very easy. 15x minus 4x will give us 11x. 2 plus 1 equals plus 3. So this is my final answer. I have simplified the algebraic expression to 11x plus 3. Example number 2. We have got 10, then we've got bracket p minus 2, close the bracket, plus 12p. In this scenario, we need to expand the bracket first. So all I do is 10 multiplied with p, and then 10 multiplied with minus 2. So let's do that first. 10 multiplied with p, and then 10 multiplied with minus 2. 10 multiplied with p will give me 10p, and 10 multiplied with minus 2 will give me minus 20. Now let's write down each term. So what I have now is 10p minus 20, and then plus 12p, which I have at the end here. Can I collect the like terms together? The like terms in this are 10p and 12p. So yes, 10p plus 12p is going to give us 22p, and then I have just the one term, which is a constant, which is minus 20, so minus 20. There we go. That's my final answer to simplifying this question. I've given you a third example, which is a written question. So let's have a read. Each side of a square has a length of 1.5x plus 1.25 meters. Multiply 4 multiplied 1.5x plus 1.25 to write an expression that represents the perimeter of a square. So let's put this into illustration. Let's draw a simple square. Apologies for my bad drawing. So each side of this square is 4 multiplied by 1.5x plus 1.25. Why do we have this 4? a square has 4 sides, 1, 2, 3, and 4. Hence why, to work out the perimeter, we have to add up each side. So all 4 sides need adding up, as all 4 sides are equal to 1.5x plus 1.25. So let's expand the brackets. So first of all, we're going to multiply 4 with 1.5x and then 4 with 1.25. 4 multiplied by 1.5x is going to give us 6x, and 4 multiplied with 1.25 is going to give us 5. There we go. Now, we need to write this as an algebraic expression, so my final answer is going to be 6x plus 5. This is the perimeter of the square. That's what this represents. So this was simplifying algebraic expressions. I hope this has helped you. If not, you can always go to Reveal Math Book, which my students already have. You can practice more examples on page 241. And also, if you are familiar with the Alif platform that we use, you can also visit lesson number 72 and lesson number 73. Thank you very much for watching.